Hi General Math students, we're going to apply our understanding of sequences as a series to a real life example here. An example in the context of a factory worker producing or processing electronic components. Okay, so let's have a look. On the first day, this factory worker processes 48 components, and then that's going to increase by 5 each day. So we'll fill in this table based on that information. Okay, now we'll go ahead and graph this. So we've got day down here, day 1, 2, 3, 4, 5, 6. And then we'll have the items up here. We go up to 73 items. So I think if we go up in 10, 20, 30, 40, 50, 60, 70, 80, that'll look pretty good. So on day 1, we have 48 items. And we'll plot the rest of these. Day 5, it's 68, and finally 73 on day 6. Okay, so part A is done. Part B asks what feature of the graph indicates a linear increase. Well, the data points form a straight line. Well, this graph forms a straight line, so that's the reason that we can see this linear increase. The data points form a straight line. Righto. An arithmetic sequence that could describe this, give the sequence rule. So we have the general rule for an arithmetic sequence looks like this. Right, so we know the first term and we know the common difference. We're going to put those in and simplify. You might want to pause the video and try that on your own first, then I'll do it. Okay, so in this case we've got A is 48 and D is 5. We'll expand these brackets here and we get 48 plus 5n take 5. So 48 take 5 is 43. So our sequence rule, 5n plus 43. Now that's the simplified sequence rule. All right, if you're asked to simplify, you need to give that. This rule, this is fine. This is the rule for the sequence as well. But if you're asked to simplify it, then we need to go all the way to this. How many items will be processed on the 10th day? Assuming this improvement is maintained, so n equal to 10. So the 10th term is 5 by 10 plus 43, using the sequence rule, 93 items. How many items will the worker have processed in total? So we're looking for the sum here, the sum to the 10th term, right? Now we know the last term is 93 and we know the first term, so we could use this formula where we have n over 2 times the first plus the last. And we'll check using both the options. The other one, of course, is this formula. Right? Okay, so if we're using first and last, we have 10 terms. First term 43, that's right, isn't it? 48, beg your pardon, 48, 93. So that way we get 48 plus 93. Oops, that's not what we're after. That's better. 48 plus 93 705 items altogether. Just show you that there. Now the other way would look like this, using the other formula. Just let this catch up. I'll just type that into the calculator as it would. Whoops, that's not what we're after. As it would look, because is PowerPoint caught up yet? Oh, there we go. Okay, 2 by 48 plus 5. Okay, that's what we want to type in, and we should get the same again. I'm going to write it down because I'm feeling so confident about that. Okay, so 10 over 2 better charge my PC shortly. Okay, and we get 705 again. So before the battery runs out on my computer, I'll just remind you to have a look at the description for the video and go ahead and try some of these applied type sequences and series questions. Okay, thanks for watching.